Hello, everyone. So this will be Unit 4 for the 197 of 9. For this lecture or for this unit, we'll be discussing GUI, showing text, game, as well as giving inputs from mouse clicks forth. The prototype that we will be doing for this lesson on Unit 4 would look something like this. Have fruits, other objects that are spawning from below and then they are upwards, and we click sort of like fruit if you've heard that name before. So we have three good objects, which are the fruits. Pear, for example, here's the example. If I click on the pear like this, our score increases 3. I click on apple, one pear. Here's an apple, the score increases by 1. Here's an apple, 1, as well as there is particle effect. Click it as there is the object is destroyed now when you click flying object. Okay. If I click on the bomb, there is also an explosion and our score decrease. Very simple game so far. This now. Let's start by loading assets game. So this again is the ones from code. We will skip unit 4 for this Unity course. No, I think we have discussed some of the topics for when we are doing. But we will be skipping to Unit 5 user. But for this course, this will course. But for this one, we should go to lesson 5.1. Click download. I've already downloaded files. Let's go straight to. So I've already created another like new project here. Fresh. Yet. So the first thing we want to do is import our assets. Assets, import package. Then files. Prototype 5. We'll use this for pin. Import everything. See, here. Okay. So our scenes folder, we have our sample 5. We don't really need our sample. I'll just drag your prototype 5 here in the remove. I'll just delete our game. Our game looks 3D now because we are using the 3D engine, but gameplay is looking like D because there is just a y plane, xy coordinate, and flying up. So currently, if we look at this, have our main camera. Let's click under the scene view. Click on F or press F rather. You'll see that this is okay, like so. It is pointed towards the screen, and for this one, our camera here has aspect, but since we will only be using the center board, I have a custom 750 by 7. It's basically a square uh, aspect ratio. Here you can add it by clicking on this, and you could have fixed resolution or whatever, aspect ratio or resolution. For this one, I did fixed resolution of 750 by 700 pixels. That will limit our camera this square that is viewing this background. We could also, in our scene view, so we could edit it better, we could click on this button here, 2D, which will set our perspective. Keep in mind, this doesn't change the physics. It is still using our engine. However, the perspective is here. We can have another note is that our projection here for our camera is set to orthographic. That is very much like if we switch it back to perspective, it looks different. Camera is back. Okay, the first thing we'll do is let's make some targets for us to click on. Those routes that are flying up and down. Game. Let's go to course library under prefabs, props rather. We have bad balls. We have barrels, so you can have barrels as well as targets. You have food. You could have balls. A ball here. I'll drag it. The hierarchies or eyeball looks like that. Personally, I don't feel like it. Let's just food. Foods I've selected previously apple or apples here. So these are two apples that are green and red apples. Size scaling here is 2, but I think yeah, a bit more. Another one I did was this mechanic pair. Drag it here and see. Okay. Okay. So we have three prefabs or three sort of good click on. Then we'll also have one bad object click on, and for that I'll bomb. This is similar to the bomb we used in type 3. Okay, have all of these. Move. Okay, so since these are all targets, we can just create color scripts for them and script now. So let's go back to our assets folder. Let's here scripts. Scripts. I'll just go ahead and folder for tabs. So I'll just tabs on scripts. Script here. Get movement. Or just simply target. This will be the script for okay. Could select all hierarchy. This will add target. Target script is attached to all of these. Then I'll just rename this weird one food 3 and bomb. I'll just this. Then Let's move on to coding for the targets now. The first thing we want to do here is just make them fly, and then we'll also add rotation. Um, it spins while it is. Okay. Double click on target and that. Okay. So, what we want to do here is just when we when we hit the object will just fly upwards. That we will be adding force, just like jumping three. Won't really be needing the update here because we'll just add force at the start. You could also do something with update, but this specific example, I'll just serialize some fields here. The variables that we will be using this field flow. Uh, so for the vertical force that we'll be adding to the object, I want it to be a force and there's force and then so say we'll have a min force up and then let's put this at the 10. Good. Then we'll also have max up. Okay. Then lastly, we also want the sort of station. For that, we will be what is called torque. Now, torque, if you remember in physics, that is force that is applied to a rotating, turning. Have a lever rotating at a certain focal point and or adding. We will name this torque. S10 float. Okay. We should also add. I forgot more components. Our objects. All of these three rigid body. I will leave that as. Then we will also sliders. Yes, I'll just for all of them and then adjust size of our food one. I guess that collider to be a bit bigger, so I'll just adjust it. So good. Two. Well, and then I'm holding Alt so it expands on all sides. So F so it focuses. So this one I want this to be a bit narrower, so I'll just put it like there. You should click on sort of like the main body of the sort of like that. I guess bomb as well will reduce the collider a bit to the body of. Okay. Okay. Going back to the scripts, we'll need a reference to our rigid body if we want to apply physics. Have a private rigid body component here or rigid body variable. A reference to body. We target RB. Then we'll get that reference here at start. Target RB. Okay. Equal to what we want to do with rigid body here is add force, right? Target target RB force want apply. So this will require a vector, right? Since it's going up, we could use vector up, up, no? This is basically shorthand for 1, 0, so 1 in positive. Other parameter for this is mode, which putting a force on impact. One time thing, vector 3 dot up, we will multiply this in force or mass. For now, doing one that is multiplied by r. Just to test things out where, but we will also need sort of torque. For the spinning, we don't really test it. Have float here for a random station. Float, random torque. This torque. Random range 10 to RB instead of add force. We torque. This one, similar to our add force, this also requires a vector 3. This one, just to simplify things, I will vector 3 dot 1. So this is a shorthand vector that is 1 by 1 by 1. And then I'll simply multiply. Force mode here is also filing. Other note, we want to below. And so right now, look at script. Our min force up is here. Are flying. We're just testing screen. Okay, flies about. Flies a bit about there. Okay, that's for the minimum. Up, out, and right. Currently at 10. Maximum force is about there. Want it. Okay, 15 is way off the screen. We'll reduce it. that is for the torque. Maybe since force is we have established our minimum force and maximum force. Actually, move this will well worry about the field force mode. Okay, that should there. It's higher than to organize things. We could methods code. I'll add a random up turn type is well all. Okay, that's a bit better, and our code is we don't actually want these things to be spawning here, no? Or in the hierarchy at the start of the game, we actually want a sort of a game of them. So we'll make sort of a spawner object. So this is we have done this a lot of times already. Just a spawner or a spawner. It's script spawner, and for that one, we'll put as this spawned by our target. You are following the create with code will instruct you, or the instructor there will instruct create a game manager. However, I would like this approach better, no? And then modularize our code as well as our spawner. We'll just touch the spawn. We want to touch score, for example, on we'll just touch the script or score manager. Okay. For target spawner, it is here, right here at the bottom. We'll add script for it, which we'll just hit a okay. So first thing we have to do is to declare some variables here. If we are spawning some things, we need right. So private float with f for now, so it spawns every second, right? Then we also want to randomize point, so I will realize a field for a in x spawn. This is minimum x coordinate. We'll measure this with it in a prefab here in for drag a cut it at want our prefabs to be at 4.3 for the minimum x, max. We also need to have a list of our objects. Realize a field, private. We'll use a list for this. We can also use an array, but this will just list of game objects. Okay, so for this, we'll just plug it in a remove one rate as one f. Guys, we can change one and we don't have and this. We can add objects here. Since we have four objects, now we can just drag our elements here. We'll be selecting like a randomized index for. Okay, start. I'll just use or I'll just create some it's here private with a on random object. Then I will create method private get instead of void actually turning for get random target. We'll just take the list or we'll get a random number with range. And for this, we want int x random range, and this should be int because then this int this is the range is from 0, which is the first index, and whichever the size is the targets. Count the count of the target. We have 4 here, but since this is a int range random range, it exceeds 4, so this will only use a random index of. Okay, so we'll use that random object or random index return targets. Then from spawn, we'll randomize some things. We'll do vector 3. This is for the point. Get for the random spawn location, we want it spawned below the screen y. And we want the x coordinate randomized. We could have turn vector 3. So instead of new vector 3, we'll use existing vectors, such as vector 3 down. Our vector 3 dot down is shorthand for 0, negative 0. So we want it to be below the screen. We won't multiply this with anything, but we will add the vector 3 dot, in this case, right, because right is 100, which is the, and then we'll just multiply the x score. We'll call it random, not yet existing. So hit that here. Put in this case range there. Okay, we return this vector 3 dot down. So it's 0, negative 1, 0 plus whatever here. So example, you have 0, 1, 0, 0, right, as a vector. Then for example, we randomized vector 3 that right is 0, 1, 0, 0, and then our random coordinate x 3 that. So then when you evaluate this, it will become 0, 3, because 1 times 100 times 3 is 300, and then we add the 1, negative 1 from the down, 1, and that is. So we'll use that with object target at okay. We'll call this at the start and we'll do some repeats. Invoke this, but we'll do. But let's test it. Works. I'll play. It will just spawn, right? Very start there. It spawned one, and then it. But that's just, we want it to spawn infinitely every. For that we can use poke repeating, but we can also use different things such as routines. Now coroutines, we need a method we will call as a coroutine. Is basically backend comsci 125. This is sort of another thread, or it is another function or another instruction that runs parallel our Unity engine. In this case, for that method to be call it created as a coroutine, we need to return it as I enumerate. This is the return type. Okay, we'll call this spawn targets, and then we have this special return type which is yield return yield wait for. Okay, so to explain, yield return here is sort of different from our normal return, where in this case vector 3 here return like this, right? It is different because this one returns a vector 3. The return yield return new wait for seconds here doesn't actually like return number of seconds to wait for. Wait for seconds here is the number of seconds, or yeah, the number of seconds that for. But yield return specifically says that the execution will go back to unity. Because when you have a while loop here, for example, and you don't have yield return, the execution will not go back to unity and will stay on your coroutine. So, wala siya pasa-pasa, or it's not passing back the execution to Unity, so it might not execute some parts of your code in specifically update, etc. So to give back the execution to Unity, we need yield return. If some of you done something like this, yield return and then not. So what this means is it doesn't really need to wait for a set number of seconds. In this case, this will just wait for the next frame. So in update, right? In update, it is running frame by frame. So in this case, it passes back the execution to Unity for exactly just one frame, and then we will. But for this example, we won't use that. We will do new wait for seconds. What we want to do here is we'll create a while loop. So you already know what it is. I'll do while true, so it on indefinite as this braces, and then we'll just call. Okay, so it will wait for. So it will wait for the spawn rate and then spawn random object. You could also put it here where it will spawn a random object and then wait for. But for this example, I will put it after the spawn rate, which gives the player, or which gives us sort of like 1 second before any of the food starts going up and right. Test it. Still in scene view for now. Waits for 1 second and then starts. Oh, I have not called the coroutine. So we have the coroutine here set, but I forgot to call it in start. Okay, start, so meaning when the game starts or when the object spawns now, but in this already in the hierarchy, so when the game starts, we will call the coroutine. So that for that we will we'll need start coroutine, and then this just requires the function. Okay, so we are passing the function of function. The special. The good thing about this is uh, that we can't do in invoke is we can actually pass parameters. Say we if you want to pass the spawn rate, you can pass it, but now we won't have any. But in the future, if you want to pass parameters to your parallel processing, then you may do some parameters. Okay, that should be better now. Click play. There. Food going up. There they are also providing some sliders. Another thing I want to do here actually is limit our digit box. We want this main position doesn't end from us to this or casting to and from the screen. Okay. Okay. I'll just play again and then we'll observe what right. So our food and our bomb are now spawned. Definitely. But then with any spawning that we do, they just spawn and then they don't. For that, we'll do vector that we'll use to. The scene actually already has a sense. That is, look at what it is. Basically, it is just one uh, empty game object with a box collider. So, so what we want here, there is a box collider that is already a trigger. What we want to do is simply just code the behavior and then right. We'll just code the behavior for this. This will say target player. This does is actually just sends collisions, sends triggers it in script. It doesn't need start, doesn't need update. What it only the only thing it needs is void on trigger, right? Thing there's our trigger will just destroy it. Parameter here either destroy other again the here right. There are and when it touches the sense trigger enter here, it will simply erase this far away from her. Okay. Another thing we want to do is have sort of inputs to our game. For this, we will simply just destroy food whenever we click. Okay. For that, we'll just edit the target. Well, so Unity, we don't have to track the mouse. We don't have to track. Well, in your future games, maybe you want to track the mouse. What we want to track here is just if we clicked on something, right? And luckily, we already have methods for that that are implemented by use. Specifically, we have on on down, which we can over private. This is on mouse down. We also have things like private on up, and we could have on mouse A. So we have these things. But for now, we only need on mouse down. So basically, on mouse down is when we click at an object. But that object should also have a collider, right? But since our food here already have colliders, then that's not really a problem. On mouse up is when you click off of a food. We don't of an object rather. We don't need on mouse up here. We just need on mouse down. We just need to do something when our object or our game object is clicked. Again, very important is your object should have a collider. So on mouse down, what we say here, we just destroy, right? We destroy the game. Okay, we'll just destroy game object. You could do this, no? Destroy game object, but sometimes I'd like to use the this keyword. Remember this from OOP Java or Python. This is self, no? This just refers to the object. This script, right? We'll just call the game object actual game. So this is not really required, no? Or this here, if just put a game object like so, it's just the same thing. But sometimes I'd like to add this, no, just to signify that we are destroying this game object, whatever game object. Okay, so let's try running this game. Let's see what the behavior is when we click on things. Okay, there it flies. I'll click on this one and it gets destroyed. I'll click on that. I'll click on this. I'll click on the bomb. Click on that apple. Click on the bomb. Pear, pear, apple. Oops, apple, bomb, pear. There. Whenever I click on something, it gets destroyed. Like that. If I don't click on it, it will be destroyed by the sensor. There, so you have sort of like bare bones of the game. For next lecture, we will add some score here. We'll add a score counter here, and we'll add some visual effects things, as well as an up score. Uh, Other things that we'll add here is difficulty. Add faster spawn rate, or uh, more objects to spawn, or more bombs to spawn, etc. Okay, but for now, we'll end things here. See you next meeting.